A modern factory is never really still. Pallets leave receiving docks, parts slide toward assembly lines, finished goods stack into racks, and trucks back in for the next load before the last one is gone. Before the forklift, that motion was broken into muscle and delay. Heavy loads were dragged, carried, hoisted or shoved by crews who worked around the limits of the human body. So how did one ugly little utility vehicle reshape factories around speed, flow and logistics? The trail begins in 1917 with a shop-built Clark machine called the truck tractor. In the early 20th century, a factory did not just need machines to cut, stamp, cast or assemble parts. It needed an entire second system to move those parts from one place to the next. That system was mostly human muscle, helped by hand trucks, push carts, overhead cranes, chain hoists, floor rails and rail spurs that ran directly into industrial buildings. A load might leave one machine on a cart, wait for a crew, get lifted by a hoist, be lowered onto another cart, then wait again before the next operation could begin. Every transfer added friction. Workers had to be available. Aisles had to stay clear. Loads had to be balanced, hooked, pushed, pulled or guided by hand. If a crane served multiple stations, the material waited for the crane. If a cart could not carry enough weight, the job was split into smaller trips. This changed the shape of the factory itself. Layouts were not planned only around the best sequence of manufacturing. They were planned around where cranes could reach, where carts could roll, where rails could be installed, and how far crews could move heavy material without exhausting themselves or blocking production. The result was a factory full of piles, castings, forgings, crates, and unfinished parts collected between operations because movement was slow enough to become a buffer. Space that could have been used for production became storage for work waiting to be moved. For a company like Clark, this was not an abstract problem. Clark built heavy axle components, and those parts had to travel through the plant before they could ever leave it. At a certain weight and volume, moving the product became its own production crisis. At Clark Equipment Company, the breakthrough began as a shop floor fix, not a grand product launch. Around 1917, Clark built a small gasoline-powered industrial tractor for use inside its own plant. The company called it the truck tractor. Its job was simple: pull heavy loads through the factory without depending on teams of workers, horses, or fixed rail systems. The machine was low, compact, and practical. It could tow trailers loaded with axle parts, castings, tools, and materials from one department to another. It could also carry certain loads on its own frame. For a plant dealing with heavy components, that meant movement no longer had to wait for a crew to be gathered or a cart to be pushed by hand. This was not yet the forklift people recognize today. It did not have the tall vertical mast. It did not raise pallets into warehouse racks. The key innovation was powered horizontal movement inside an industrial building. Clark had created a machine that could repeat the same hauling task all day, with far less strain and delay. That mattered because factory transport was becoming a production step in its own right. If a part could be moved faster between machines, the next operation could start sooner. If one tractor could pull a loaded train of trailers, fewer workers were tied up in hauling. The plant gained speed without changing the machines that made the parts. The truck tractor proved useful enough that it did not stay a private tool for long. Visitors to Clark's plant saw the little tractor doing work that their own factories still handled by hand. They asked where they could buy one. Clark had built the truck tractor to solve an internal bottleneck. By doing that, it accidentally revealed a market. The modern material handling industry did not begin with a polished showroom idea. It began with a factory looking at its own floor and deciding the old way of moving things was too slow. The missing breakthrough was vertical movement. A powered tractor could pull a heavy load across a factory floor, but the load still had to be raised, lowered and positioned by people, hoists or cranes. That kept the tractor tied to the old layout of the plant. Materials could move faster from place to place, but they still lived at floor level. The next step was to put lifting equipment directly onto the vehicle. Early lift trucks experimented with platforms, winches, chains, and simple elevating frames. The goal was practical. Let the same machine that moved the load also pick it up and set it down. Hydraulics made that idea reliable. A hydraulic lift could raise heavy weight in a controlled motion without depending on a worker's strength. Oil under pressure pushed cylinders upward, and the driver could lift or lower the load with precision. This made the truck more than a towing machine. It became a mobile lifting tool. The vertical mast gave the lift a guided path. Instead of swinging like a crane, the load rose straight up and came straight down. Forks then gave the machine a direct way to handle skids, boxes, and eventually standardised pallets. Slide the forks under the load, lift it, drive it, and place it where it needed to go. That created a new engineering problem. If the load sat in front of the vehicle, the truck could tip forward. The answer was the counterbalanced design. Heavy weight at the rear of the machine offset the load at the front, allowing one driver to carry materials that had once required crews, carts, and separate lifting gear. No single company invented the forklift in one clean moment. Different manufacturers tested different frames, controls, masts, and lifting systems. Clark became one of the major early builders, but the modern lift truck emerged from a series of improvements across the industry. Once those pieces came together, factories changed shape. Goods no longer had to spread across the floor. They could be lifted, stacked, and stored upward. The forklift did not just move materials faster, it made the vertical space of the factory usable. The forklift needed a load it could trust. Loose boxes, barrels, sacks, and machine parts were difficult to lift cleanly. Some could roll, some could collapse, some were too uneven for forks to slide under. The machine was ready to move materials quickly, but the materials themselves were still being handled as separate objects. The pallet solved that problem by turning many small items into one stable unit. Workers could stack goods on a flat wooden platform, secure them if needed, and leave enough space underneath for the forks to enter. The forklift no longer had to deal with every box or crate. It only had to deal with the pallet. This changed the basic math of factory movement. If a shipment contained 40 cartons, workers no longer had to carry or cart those cartons one by one. They could build a single palletized load, lift it in seconds, drive it across the floor, and set it down as one piece. Labour shifted from repeated handling to preparing and moving unit loads. That idea became known as unit load thinking. The goal was not just to make the truck faster, the goal was to reduce the number of times people touched the product. Every touch cost time, created damage, and slowed the flow between receiving, production, storage, and shipping. Once pallets became common, the building around them began to change. Receiving docks were arranged so pallet loads could move directly from trucks into storage. Shipping areas were planned around staged pallet positions. Aisles had to be wide enough for turning forklifts. Floors needed to be strong and smooth enough for loaded wheels. Storage changed as well. Pallet racks allowed goods to be stacked in organised vertical rows instead of scattered in piles across the floor. A warehouse could hold more material in the same footprint, and workers could retrieve specific loads without moving everything around them. Standard pallet sizes made the system even more powerful. Trucks, shelves, doorways, and packaging could be designed around predictable dimensions. The forklift became the link between all of them. The real breakthrough was not a machine working alone. It was a new system of packaging, spacing, storage, and movement, with the pallet giving the forklift something the entire factory could organise around. World War II turned material handling from a factory improvement into a military necessity. Armies did not just need rifles and tanks. They needed ammunition, fuel, food, uniforms, aircraft parts, medical supplies, spare engines, and repair tools moving through factories, depots, ports, ships, and forward bases. A delay in a warehouse could become a delay at the front. Manual handling could not keep up with that scale. Crates had to be unloaded from rail cars, sorted in depots, staged near docks, packed into ships, and unloaded again overseas. Every time workers broke a shipment into individual pieces, the system lost time and labour. Forklifts and pallets gave the military a way to move supplies in larger blocks. A pallet of ammunition could be built at an inland plant, carried by lift truck into storage, moved to a loading dock, and transferred toward rail or ship with fewer individual touches. The load became easier to count, easier to stage, and faster to redirect. This pressure encouraged standard practices. Depots needed predictable pallet loads. Loading docks had to match truck and rail movements. Aisles, storage areas and staging zones were arranged so lift trucks could keep freight moving instead of waiting for space. The forklift was no longer just a useful machine inside one building. It became part of a chain. War also trained people to think differently. Officers, engineers, warehouse supervisors and workers began looking at supplies as flows through a system. The question was not only how fast a truck could lift, it was how quickly material could pass from production to storage, from storage to transport, and from transport to use. That feedback loop mattered. The demand for speed pushed better equipment, better pallet methods, better dock layouts and better scheduling. Those improvements then made it possible to handle even greater volume. When the war ended, the habits did not disappear. Thousands of people had seen what organised material handling could do under pressure. The same logic came home to civilian factories, where the forklift and pallet were ready to rebuild production around movement, storage and speed. After the war, the forklift changed what a factory could physically be. Older factories often treated storage as a fixed place and movement as a necessary interruption. Workers pushed carts, carried parts, waited for cranes, or stacked materials where floor space happened to be available. Production could stop because a heavy component was still sitting across the building. Powered lift trucks made movement part of the design. A pallet of castings could arrive by truck, be lifted at the dock, placed into racking, pulled down when needed, and delivered to a machine station without being unpacked piece by piece. The factory floor became less like a collection of rooms and more like a controlled traffic system. That changed buildings. Loading docks became busier and more specialised. Aisles had to be wide enough for turning, floors had to carry heavier point loads, and storage began to rise upward on racks instead of spreading endlessly across the ground. Warehouses attached to factories became active buffers between suppliers, production lines and shipping schedules. It also changed timing. Assembly lines depended on parts arriving in sequence, not in random piles. Forklifts helped feed those lines with engines, frames, tyres, steel coils, crates of fasteners and finished sub-assemblies. Material could be staged near the next operation, removed when complete, and replaced before a worker or machine sat idle. The trade-off was real. Many jobs became less backbreaking because one operator could move what once required a crew. But lift trucks brought blind corners, crushed foot injuries, falling loads, battery and fuel hazards, and the need for formal training. Work also became tied more tightly to schedules, dispatch orders, and the pace of machines. By the late 20th century, factories and warehouses were no longer separate worlds. Forklifts connected receiving, storage, production, packing, and shipping into one continuous flow. They did not make goods by themselves, but they made modern production possible by keeping everything else in motion. The forklift began as Clark's truck tractor, a small shop vehicle built to move parts around a factory yard. It helped turn loose goods into palletized loads, manual hauling into powered movement, and crowded buildings into coordinated production systems. Its legacy is not just speed. It reshaped docks, aisles, storage racks, assembly lines, and the rhythm of industrial work. Thanks for watching. If you enjoyed this documentary, like, subscribe, and comment with another overlooked machine that changed the world.